Okay, that should be all set and good to go. Thank you for your patience, everybody, and thank you for everybody who is currently watching in the YouTube or on the 8x8 channel. We do have the link to the 8x8 in the YouTube chat. And if anyone is watching this after the fact, thank you for checking it out. And you can keep an eye on us in the Dev Edmonton Slack in order to get notification of these happening live. So this is our first virtual meetup. And there were a few hiccups. Hopefully we get things ironed out a little bit better for next time. But your hosts are, as usual, Andy Stechishin and me, Will Gabriel. And we are both in the 8x8 channel if you want to talk to us directly, but I'll be keeping an eye on the YouTube comments just in case anyone has any questions to relay to Karl as he puts on his presentation, or any comments in general. We do have a website. The website link is also below the YouTube video as well. You can click the link to that and get notification of any of our upcoming videos or any captured recordings of any of our meetups from the past. We're also on the Dev Edmonton Slack. You can get a quick and easy invite to that going to yegrb.com/slack. I think anyone watching this live is probably in it already, but couldn't hurt to have that extra reminder of where to go. So obviously we aren't using the Startup Edmonton facilities right now, but we still follow the same sort of code of conduct. And that basically is for everyone who is involved in these meetups, anyone in the YouTube chat, anyone who actually jumps directly into our video chat, just be great to each other. We want this to be an environment of openness, of respect and inclusivity. So keep that in mind, and everyone should get along just great. So we do have just one main presentation today, and that is native extensions for Ruby with Karl Parkinson. He's going to be on shortly here. And as I mentioned, I will be keeping an eye on the YouTube chat for any questions that people do have about him, and I can quickly pause him to ask those. We do have a little bit of news in the Ruby world. RailsConf was officially canceled for its in-person presence, which was going to be, I believe, in Portland, Oregon. But instead, it's going to be at home on your couch. They're going to be streaming all of their videos directly to wherever you are most comfortable at watching them. And that's going to be at railsconf.com. And also, if you have any repositories up on GitHub, you probably got this notification already, but there was a big security hotfix to Rails 6.0.2.2 and 5.2.4.2. Fix those. So if you have anything that is live, make sure that you update to that. So quickly for introductions, we won't spend a lot of time on this because we're not in person, but in the YouTube chat, what is your name and what for you is your social distancing silver lining? Personally for me, I've been working from home for over a month now, and work starts at 9 and grocery stores open at 8. So it's been pretty great for me to actually be able to go to the grocery store first thing in the morning and be back at home with the groceries put away before work even starts, and then have the rest of the day for whatever. So I'm going to open this up real quick to the people in the video chat. So let's start with my co-host, Andy. What about you?
I'm just amazed, Will, that you're trying to horn in on the seniors' time when people of my age are actually, you know, trying to get our desperate groceries without being infected by you youngins who aren't.
Seniors' time is from 7 to 8, so it's okay from 8 to 9. Okay. Yeah. I'm completely respectful.
We have to stand up for ourselves anyway. So I'm Andy Stechishin. My social distancing silver lining was that 4 days before I got the work from home order, I had started a new contract that required me to be in an office. And so when the work from home order came, I was gladly returned to the comfortable office that you now see behind me, where I am most happy.
Very nice. All right, how about you, Karl?
Sure, so I'll show my face. Hey everyone, I'm Karl, I'm a developer at Jobber. My social distancing silver lining, I don't know, I think like a lot of people I've just been learning how to bake fancy breads, which is kind of fun.
Very nice. And we have Chris in this chat as well. Are you mic'd up there, Chris?
I think so, if everyone can hear me.
Yep.
Yeah, hi, my name's Chris C, and I've been to, you probably seen me at a couple of Ruby meetups before. And what's my social distancing silver lining? I guess just because all my evenings are free, because my daughter, all her events were canceled. You know, the couple of things my wife and I would do in the evenings are all canceled. So I've been playing a lot of video and board games over the past couple of weeks, like more than I think I've played in like all of last year. So
very nice.
My silver lining.
Yeah, it's nice to be able to get caught up on that all of a sudden when you find yourself with this unusual amount of spare time.
And the nice thing is all my friends suddenly have lots of spare times too, because their kids don't have anything to do in the evening. So we have to get together virtually, but it's been nice.
Awesome. So we've got a couple of responses in the chat as well. Mark says that he's been homeschooling his kids. It's been amazing spending time with them and seeing them. That's pretty awesome. Cody started streaming, and that's pretty cool. If you want to plug that in the chat, we'd be happy to have you share that. And Cody has been 3D printing more during the day. That's pretty cool too, because that's something that you have to be able to keep an eye on. If your prints go wrong halfway through, then you're pretty much SOL. So cool. So that's it for introductions. We do have normally this time to set aside for people to share job opportunities. We're just going to put that in the YouTube chat right now. If anyone is looking for work or has Ruby or Rails based opportunities available that they'd like to share, please share that in the chat for the people who are looking to take advantage of that. So that is it for our introduction. We're going to move things over to Karl. So Karl, have you got everything set up on your end?
Yeah, I will just start sharing my screen.
So while we're waiting here in the chat, Mark does mention that CodeVid 19, which is a hackathon that's specifically geared toward social solutions for the interesting times we're living in right now, still needs volunteers. So if anyone wants to click that link for him, that'd be awesome. I believe he was only asking for a couple of hours of time from each volunteer. Is that correct, Mark? Now we see you.
Oh, maybe I just had. Okay, I had to have my camera on apparently. Didn't realize that. Okay, you're seeing the slides okay?
Yep.
Yeah, okay, cool. In that case, let's get into it. Yeah, so I'm going to be talking about building what are called native Ruby extensions. And there's going to be a little bit of attempted live coding here. And I have all the code that I'm going to be writing up on a GitHub repository, which I've just put in the bottom of the link here. And then I can share up the slides after the meetup. So this is a fairly advanced Ruby topic. So I'm going to try and make it as accessible as possible. And to do that, we'll have to start with some pretty basic first principles. So let's just have a brief detour to talk about kind of the fundamentals of how Ruby works. So what is a programming language? So there's a few definitions of a programming language. You can talk about the syntax of the language, the semantics, the type system, whether it's statically typed, dynamically typed, etc. But really fundamentally, a programming language is just a way that we use to instruct a computer to perform a task. So how are programs executed? In modern computers, they're executed by the CPU. But the CPU is not able to read and understand Ruby and execute the instructions therein. So we need a way that we can take our Ruby code and turn it into CPU executable machine code. And that's not the case just for Ruby. That's the case for all high-level programming languages that developers use. And there's generally two types of languages. There's your compiled languages and your interpreted languages. So compiled languages are things like C and Java. And in that paradigm, you have a program called a compiler. And what the compiler does is it will basically it reads the code, it reads your source code in, and then it basically outputs machine executable code. And compiled languages do that up front, and then the thing that is executed is the resulting machine executable code. And then versus interpreted languages, which kind of on the will, basically your source code is read in, and then it's kind of line by line, it's parsed and converted into machine code for that line, and then executed, and then moves on to the next line. That's a bit of a simplification. The reality of compiled interpreted language is a bit more nuanced than that, but at a high level, that's kind of how they work. And so Ruby is an interpreted language. So what does that mean? So let's talk about how Ruby actually executes. So there's a separate program which parses your Ruby code, interprets it, and then executes the resulting machine code. So you may have heard of a few of these. MRI is the, I believe that's the most popular one. It stands for the Match Ruby Interpreter, and it's written in C. And I believe MRI recently got replaced by YEGRB, which stands for Yet Another Ruby VM. I think that happened as of Ruby. I'm blanking on it. Might be Ruby 2. I'm not sure. I'll double check that. But there's also other implementations of Ruby. Another popular one is JRuby. And what JRuby is it's basically a Ruby interpreter written in Java. So then you can execute your Ruby programs in the Java virtual machine environment. And there's various reasons why you would want to do that, depending on what kind of hardware you're wanting to run your code on. Having it in the JVM might help. Also, JRuby opens up the ability to write native extensions in Java, which might be useful to you depending on your skill set and what you're trying to accomplish. So Ruby in the MRI or the YEGRB implementation is executed via a virtual machine. So what that means is that what we call the Ruby interpreter is essentially just a virtual machine written in C. And so the interpreter will parse your code, and then the virtual machine basically then executes it. And this has a few advantages. It gets us some portability so that we don't have to worry about, having a separate interpreter needed for Mac versus Windows versus Unix systems, things like that. But so at the end of the day, the interpreter, it takes your Ruby code and it actually, essentially, it interprets it into C code, and then the C code is executed by the CPU. Again, that's a bit of an oversimplification of what actually happens, but for the purposes of what we're going to be talking about here. So what is a native extension? A native extension basically just means that you kind of skip the interpretation step. So instead of writing Ruby code, which is then interpreted by the interpreter and transformed into C code, which then is transformed into machine code, you just write the C code directly, and then it just gets executed by the Ruby virtual machine. So there's no interpretation step. And the reason you would do this is, as far as I can tell, solely for performance benefits. An interpreted language like Ruby, no matter how many kind of optimizations we put into the interpretation process, it's always going to be slower than a compiled language like C or Java, which normally is fine, because most applications written in Ruby or Ruby on Rails are not necessarily performance intensive, and you're not necessarily wanting or needing to have the quickest execution time you can, but sometimes that is important. An example is the Nokogiri gem, which I believe most Ruby or Rails projects use, which parses XML and HTML and other things. That's a case where performance is very important, because if your XML or your HTML parsing is slow, then that can slow down anything that is waiting on that to happen. And so that gem is written almost entirely in native code. And then when you install it, you actually have to compile the native code so that it can be run. So we're going to dive into a coding example. And what we're going to do is pretty simple example. We're just going to define a module. And then we're going to, within that module, define a class. And then from that class, we're going to define a couple methods. And then we're going to do a performance comparison between just the standard Ruby implementation of this module and class, and then the native code implementation of the module. So I just need to switch what screen I am sharing. Okay, so what we have here is just a...
Oh, it looks like it's not coming in.
Okay, 1 second. Let me stop sharing again. And is that working now?
Just blank.
Oh, okay.
Oh, there we go. Got it.
Apparently stop sharing turns your camera off for some reason. I don't know why it does that. Anyways, apologies. So what I've set up here is just a very basic gem. And if you want to have your gem compile native code, then there's a little bit of boilerplate that you have to add. So I'll just go over it quickly because it's not all that exciting. But you have to make sure that the gem files includes the ext folder, and then within the lib folder, any compiled code that you want to execute has to be included. And as well, you have to add spec.extend. You have to add 2 spec.extensions. This ext / the name of your gem / this extconf.rb file. And as well as a development dependency, you need to have the rake-compiler task. And so then in the rake file for the gem, you need to require the rake/extension task. And that's all you have to do with the rake file. And then you're going to want to create the extension ext folder, and then there's just a little bit of, again, boilerplate in the extconf.rb file. So you have to require this make mf module, register the name of the extension, configure the directory, and then just call this create makefile. And what that does is that just creates a makefile which the rake compile task can then use to actually compile your native code. So let's take a look. In plain Ruby, this is what we're going to do. So you can see it's pretty simple. We're going to define a module. We're going to make a class. Class is going to have an initializer. It's going to have a method which adds 2 numbers together. And then it's going to have a method which loops over 3 arrays and then just multiplies all the values of each array together and then spits out the resulting array. And this is a bit of a contrived example, but it's just meant to demonstrate the performance benefits that you can get if you have a very critical but unperformant section of code. So, what you're going to want. So what we have is in the ext folder. You can see we have the super.c file, and so this is where we're going to have all our native code. So the first thing we're going to want to do is just include the ruby.h header file. And so what this is essentially the file that contains all the functions and C macros that the Ruby interpreter exposes for use in writing native code that you want to compile and be executed. So Ruby essentially has it's called the C API for Ruby, and it's documented on the Ruby website. And I can send a link out to that into the chat in a minute. So essentially, this is just setting up that we can use the C API. So first, let's just declare a couple things. Let's declare our module. And let's declare our class here. And pardon me. For native extensions, you need an init method. And the convention is basically just init and then just kind of the name of your gem or whatever you're calling it. So that's what this init super method is. And then we want to have an initialize method. And so that's it for now. So the Ruby interpreter basically exposes all these RB define methods. So this one is called RB define module. And then you just pass this string of what you want the module to be called. So what this method does is so basically it tells the Ruby interpreter, hey, I want to define a Ruby module. And then the interpreter will do whatever it needs to do to accomplish that. And I'm guessing that when the interpreter is just going over just your standard Ruby code, like right here, probably under the hood, there's a RB define module method that is underpinning this module declaration. And we can do the same thing with class. So we just call RB define class. Actually, RB define class under, since we're defining it under a module. Pass in the module what we want the name of the class to be. I'm going to uppercase these. And then you have to pass in what the class is inheriting from. And Ruby is an object-oriented language, so technically everything is an object. And even classes that don't explicitly inherit from something, implicitly they inherit from the base object class. So that's what this is. And so that is it for the init method for the time being. So now we need to define this super. Basically, this is the C definition of the initialize method.
I think you have a spelling error in initialize.
Oh, yes, I do. Thank you for catching that.
They're consistent, so maybe it won't matter.
Yeah, we'll just go with it for now, but you are right.
You can always trace who's copied your code that way, right?
Yeah, exactly. Yeah, so this initialize method, if we look back at the plain Ruby, doesn't actually do anything. We're not setting up any instance variables. So basically, it's just going to return self. And self is, this is just kind of the implied class that the method belongs to, if that makes sense. So that is always an argument that you pass when you're defining class methods in native code. So now,
does it have to be spelled correctly for the initialize? Like, because if you, in Ruby, of course, if you misspell initialize, it has special meaning. It needs an I,
yeah,
between the N and the T.
okay, well, let's compile it and see what happens.
Yeah, sure.
Okay, so it looked like it compiled fine. So you can see it compiled into the super.bundle file in the lib/super file, which you can open it if we want, but again, it's a compiled file, so it's just kind of looks like nonsense to us. But what we can do is we can test out if it works. So if we run IRB and use the -r command, and then we require, oh, I spelled that wrong, so that's not going to work. Super.bundle. Actually,
Yeah, unfortunately, when there's a lot of action on the screen, it gets quite blurry. So I think it might help to make sure that if there's something that's important, just to read it out.
okay, yeah, sure. Okay, so what I did is I was trying to require, hopefully it's not as blurry now because I'll stop typing. So with the IRB command, you can use the -r flag to tell it to require a file. And so I was just trying to tell it to require this super.bundle file here, which took a couple tries, but I think I got it now. So if I did, then we should be able to, ooh, that might not be able to be seen well. So we should be able to type the name of the module, which we defined, and we did. And then we should be able to type, again, that's the name of the class. And if it all worked, then we should actually be able to call super.new, which under the hood is calling this super initialize method. And we seem to be doing okay so far, so that's good. So let's exit out of here. And now let's try and do something a bit more exciting. So let's define this add method. So we're just going to declare it. Value num1, value num2. So you're probably asking, you might be asking what this value is. And for anyone who has a bit of experience with C programming, and I should add a disclaimer that I'm not a C programmer. I basically just know enough to kind of get by for the purposes of this presentation. So if you have in-depth C questions, I probably won't be able to answer them, but I'll do my best. But this value is basically, it's a Ruby interpreter defined. It's probably a macro under the hood, but basically it's just a type. It's the type that you have to use for all return values when you're writing native code. And I believe that's just because the interpreter is very intentional about what of its internals it exposes when you're writing native code, so that to kind of avoid you shooting yourself in the foot too badly. So basically all methods, as far as I was able to find in my research, all have this type of value, and then they have to return the type of value, and all the arguments become value arguments, which is a bit funky because as we'll see, values kind of are used to represent, we're going to use them to represent integers and arrays of integers. But yeah, so that's what this value type is. So we want to define a method. So we use RB define method, and we want this to be under superclass, so we pass that. And then this is what the name of the method should be in Ruby. So you can see that corresponds to this name here. And then for a method, you pass a basically I think it's in C called a function pointer to where the actual logic for the method will live. And then you pass the number of arguments that the method takes. And this self argument is not counted in terms of the number of arguments it takes. So we'll see that the method definition here, method signature in C, it has 3 arguments, but we're only basically defining 2 arguments for the Ruby interpreter, and that's because in Ruby it takes 2 arguments because the self is kind of implied by it being a class method. So and this is a pretty simple method. So as I said, as C is a statically typed language, you have to use some type conversions, and the Ruby, this Ruby header file gives you a few. One is num to int. So in C, you deal with either integers or doubles, whereas in Ruby, we have kind of fixed nums and I think decimal types and other things. So this num to int function is just going to take a Ruby fixed num type and convert it into a C integer type. So we're going to have to do that with both of the arguments. Then when we go to return it, to then turn it back into a Ruby number type. So again, we'll just pause a second in case my typing is making things blurry. So let's compile. And again, it compiled fine. So now let's include it. So we should be able to go, we instantiate a new instance of this class, should be able to call add. And you can see it tells us argument error, wrong number of arguments, was given no arguments, expected 2. And that's actually good. So what this is showing us is that our class has an add method, and it's expecting the right number of arguments. So let's try and see if it works. Seems to be working. Yeah, so now I'm going to demonstrate a few things. So let's say we forgot to turn this back into a num. And so now we're returning an integer type. And we can actually get some funky behavior. one thing you'll notice is that it actually compiled successfully, which you might not expect it to, since according to this method signature, we should be returning a value type, and we're returning an integer type. I'm not actually 100% sure why this compiles successfully, but my guess is that the this value macro type is accepting an integer type. Yeah, that's the best explanation I can come up with. But so if we go back into IRB, we should actually be able to do something a little funky, and you can see that we're not actually getting the correct answer back. And we may, if we're lucky, and we are, actually be able to get a seg fault and crash IRB. So I'm not going to bother scrolling up to the top, but yeah, that's what happened, which is interesting because it's not usually something you see when you're writing Ruby code. We don't have to worry about seg faults. But when you're writing a native extension, you're not actually writing Ruby code, you're writing C code or Java code, and so you have to worry about this whole other class of errors, which oftentimes don't pop up in Ruby programming. Yeah, so I just wanted to demonstrate that. Let's get this working again. We'll just change it back to a num. And now if we compile and include it, instantiate the class, now things are working again. And that's just because we got types all on the lines. We cast the integer back into a Ruby num type, and so now everything is happy. So let's move on and define this last method here. So what this is doing is it takes 3 arrays, it generates a result array, and then it just loops over the triple nested arrays and multiplies all the values together. Yeah, for people who remember their algorithms classes from university, you'll notice this is an order n cubed operation, which can be quite slow depending how big these arrays are. And as we'll see, even with fairly small arrays, this is not a very performant bit of code. That's intentional, and we're going to see what the effects of using a native compiled extension instead of plain Ruby to do this performance-intensive application are. So let's again just declare the method we want. Value R1, value R2, value R3. Again, we will call RB define method. We want this to be on the superclass. Calling it array mult. Pass pointer to where the actual logic is defined, and this one has 3 arguments. So actually, for this one, I'm just going to be a bit lazy and copy and paste it from my cheat sheet. This is the working code, because this method's a bit longer and just watching me type is not the most exciting thing. But let's talk about it. It's not. Ooh. Okay, it's not indenting properly. but I will just manually fix that. Okay, that looks better. So it takes in 3 arrays, and C arrays and Ruby arrays are very much not the same thing. In Ruby, to define an array, you basically just use these square brackets, and you can kind of shove anything you want into an array. It can be essentially as long as you want, and it's a very easy type to work with in Ruby. But in C, you have to give the array a type, and you also have to declare up front how long it is so that memory can be allocated properly. But luckily, the ruby.h header file gives us some helper functions. So it gives us this rb array new 2 method, and it gives us this array_lane method. So what this is doing is it's declaring a new array of length, the length of array 1 multiplied by the length of array 2 multiplied by the length of array 3. If we wanted, we could do this just with raw C arrays and declare, declare the size of the array ourselves. But we have these helper functions. We might as well use them. So then we're just going to loop over 3 arrays, and we're pulling out the entry from the appropriate array at the appropriate index with this re entry helper function. And much like in the add method, we have to do our type conversion. So we're converting them from Ruby num types into C integer types. And then we're going to multiply the values together. And then we're going to push the result onto the result array with casting our proper casting from int back into a num type, and then we're going to return the result array. So much like before, let's compile. And oh, this is interesting. Oh, I have a typo somewhere, I'm guessing. Oh, yes, copy paste error. Super. So what happened was this was super, the name of this pointer function was super rmult, but this was called super loops. So this pointer didn't actually point at anything. Again, this is one of those cases where I'm surprised it compiled properly, but I'm not going to delve too deep into the mysteries of the compiler at this time. So instead, let's just try again, and that time it worked. So,
but pointers to functions aren't resolved at compile time.
Okay, well there you go.
It's a runtime issue, yeah.
Yeah, thank you, Andy. As I said,
one more reason why raw C can be very fast and very dangerous.
Yes, yeah, thank you, Andy. As I said, I'm not a C programmer, so I'm basically just
I had close to 20 years of doing C programming.
Oh, yeah, there you go. Okay, so I'm just gonna make a couple arrays, and now if we instantiate an instance, and we should. Okay, so we have the method defined. That's good. It expects the right number of arguments. So if we pass it arguments, then you can see it looped through them and multiplied them together. So that is so that's our native extension. So we defined a class within a module, initialize method, an add method, and then this array multiplication method. So now let's do is let's do a performance comparison. So as I said, performance is really the reason you would want to do this. So let's compare. Right here we have the just standard Ruby implementation, loop through each array, multiply the values together. And append it to a result array. And we're going to compare that with using our native C compiled implementation here. And as I said, this is technically I've made a gem here, so we can go ahead and install the gem, the local system. So now we should be able to require it and use it here in this code. So I'm just going to confirm that it installed properly. And it seems to have done so. Okay, so let me make this a bit bigger. And I just need to go up a couple directories. And so, oh, and I should mention we're going to do, actually, let's do 10 times just to be safe to start out with. So we're just going to multiply the numbers 1 to 100. Each array is just going to contain the numbers 1 to 100. So this is 100 cubed operations, multiplication operations technically. So let's do it and see. So that was actually pretty quick. So pure Ruby, you can see it took about a second, whereas with the C extension, it took basically a 1/3 of a second. And that's actually a fairly significant savings. If you think of a hypothetical application which has to do this operation maybe 100 times a minute, you're going to see some real time savings from using a native implementation of the method rather than your just standard Ruby implementation. But let's do 100 trials instead, and this will have a bit more of a stark difference. Yeah, so you can see Ruby was 9 seconds, and with the C extension, again, it's about 3 seconds. So proportionally pretty similar, but 9 seconds versus 3 seconds, say 6 seconds. You know, your hypothetical application is doing this a lot, then you're going to see some real significant cost savings. I was actually surprised at how stark this difference was. I didn't think it would be this different just for this pretty simple operation. Yeah, I would do it 1,000 times, but I suspect we would be sitting here for a while, so I'm not going to do it 1,000 times.
Yeah, I would expect that you'd see large differences in things like integer math, whereas if you got to floating point math, your discrepancies may not be quite as large. And then depending on the complex things that you're dealing with, I mean, like with anything, you need to evaluate the number of things that you're saving and where you're spending your time, right?
Yeah, that's a good point. That this multiplication operation with integers is a pretty easy operation for any programming language to do, whereas
well, one of the things too is Ruby isn't using native types.
Yeah.
right? Because everything is an object, right? So there's that conversion. So when you convert it down into a native type, and then C, which is, those operations are being done directly on the CPU and the registers, as opposed to Ruby, which is dealing with objects and pointers into memory and combining things together. So, that's one of the contributing factors. Like with anything, when you're optimizing, it's a good thing to know what you're optimizing first, right? You might optimize a piece of code that ultimately only executes, in 3% of your application, right? So if you optimize, that, reduce it by 10 times or make it 10 times faster, but it's only 3% of your application, you've now turned your application from running in, if it takes 100 seconds, it now runs in 98. So depending on the investment to do the optimization, you need to make sure that you're hitting the areas that have the impact in what you're doing. But which is, I think, one of the reasons why something like Nokogiri does what it does.
Yeah. Yeah. So, I mean, I wouldn't recommend, I think this was a useful exercise in terms of kind of learning a bit about how Ruby works under the hood. But again, unless you have some real performance bottlenecks in your system, which are definitely being caused by the fact that it's written in Ruby code, I wouldn't necessarily recommend going crazy with writing a bunch of native extensions for your gems. Probably in most standard, kind of CRUD Rails apps, you won't ever need to do this. I would venture to say that your performance bottlenecks in those apps are going to be things to do with the database or front-end code or things of that nature. It's unlikely to necessarily be Ruby itself being such a performance bottleneck that you need to resort to using natively compiled code. But it is an option if you happen to find yourself in a scenario where it makes sense.
We got a quick question here from Chris, so I'll activate his microphone here.
Yeah, go ahead.
Hey, Carl, can you hear me?
Yeah, I can hear you.
Hey, I just questioned, did you guys ever do anything like this at Jobber? Was there an area, I don't know if you can talk about it, but was there an area that you did something like this to optimize a part of the application?
No. As far as I know, we have never had need to do this at Jobber. My motivation for this was just curiosity, just kind of wanting to learn how it works. Yeah. At Jobber, our performance bottlenecks are all database and front-end systems, not Ruby code.
Oh, okay, cool. I was just curious. Thanks.
Yeah.
Carl, we did have a question from the YouTube chat. Somebody was wondering what tool you're using to do the code in.
Oh, yeah, it's just Atom.
Okay.
Yeah.
We had a number of options come forth, and Atom was not one of them, but.
Yeah. So is there any other questions?
Yeah, I'll keep an eye on the chat here if anyone has anything that they'd like to ask to Carl. I've got a question myself in the meantime, though. I expect it might be a little intimidating for those used to high-level interpreted languages like Ruby to jump into C for the first time, or as the case may be after a 12-year gap like myself. So were there any resources that you found that you'd suggest to help kind of smooth out that transition and really highlight the things that are going to be different?
Well, so I wrote a bit of C when I was in university, but other than that, I haven't yet had to use it in my career. So just give me a second. I'll stop sharing. My Atom tab, and I'll. There's a few documentations of the Ruby C API that I can show off. Hopefully people are able to see. There we go.
Yeah, it's coming in good.
Yeah, so this one's pretty good. It's you can see it talks about the Ruby C API, and then it has this tab about running C in Ruby, and there's actually use like putting it in a gem and then compiling it is the normal way you do it. There's there's something called an FFI gem, which I thought was documented here, but it's not, and it I'll just actually find it and then share that tab.
Sure.
So it's like a different approach. It's a way to kind of dynamically load native libraries, so you can kind of pop into C without having to like write a whole gem to do it. So let me share that tab. Yeah, that's this one. So it's like you require the gem and then you kind of you like attach a I don't know exactly how this works, but you kind of like attach a function and then it kind of drops down and just uses that function in the native language.
Okay.
And then it supports callbacks from C to Ruby. But really, I just kind of found a few guides online, and I just kind of scraped together enough C knowledge to do this presentation.
Okay.
And this is the official right here. What I'm showing, this is the official doc from the Ruby people about how to write native extensions. So these docs are much more thorough, but you do have to have a bit of C knowledge, in the sense of like you have to understand that C is a statically typed language, and you have to know what type converters are a thing, which if you haven't used a language like C before, you might not know, which is, no shame in that.
Sure.
Yeah, so I would say just like kind of do a couple C basic tutorials and then just kind of try and learn from there.
All right, cool. Well, we've got another question from the chat here. Cody asks, how useful would a native extension work for network calls to external resources? For example, using something like the Google Maps API, if there would be any performance benefits in that kind of area.
That's a good question. I would
generally think no myself.
Yeah, I was gonna.
So calling a REST service from C versus calling a REST service from Ruby, the time you're going to spend is going to be in the network communications. And having done, I mean, even if you're using sockets, there's a reason why most people don't write REST apps with a C interface. It's because it's horrible and ugly.
That's fair.
Setting up these sorts of things to actually do the network calls, the Ruby layer abstracts so much of that away from you, and there's so much. So one thing about C that you don't have with Ruby is you don't have vast masses of open source libraries to allow you to do things.
Yeah.
And C is a very minimal language in the libraries that they include as well. So there's nothing like the HTTP libraries that you find in Ruby inside C. And in many cases, the stuff that you do find it's often paid.
Mm-hmm.
Right now, that might have changed in the last 10 years, but I'm not sure. But it's also difficult to compile and link in these external libraries. So, you know, for the amount of effort versus the gain that you would have, you're probably better off doing it in Ruby.
Mm-hmm.
Because the time is going to be the communications back and forth of dealing with the API and not the actual processing of the information. Right? So you'll spend a lot of time writing a whole pile of code for something that's going to take you 10 minutes in Ruby.
Right. Yeah, and it's something that it's certainly interesting to see that this kind of technique is what's behind a lot of the things that do the heavy lifting in your applications. Like you used the example of YEGRB. Image magic is going to be another example of that. You don't do image processing in Ruby, but you can jump down to a C library like that to handle that for you. Are there any spots that you've seen that would be nice places to look, to start looking, or at least where you could use this technique to help your apps run faster, or even just recognize that there's probably a native solution wrapped into a gem for you?
Well, yeah. So if you run bundle install and the output ever says it ever pauses for a while and it's stuck on compiling native extension, then you know that the gem that is being some gem you're using is compiling some native code. Again, YEGRB is a big one which does this. Off the top of my head, I'm not 100% sure. Image magic, like you mentioned. Basically, I would if you know of a gem for Ruby which does anything which you think would be like computationally expensive, maybe audio processing, I bet would be one, or like video. If there's like a video streaming gem for Ruby, I would suspect that is written in a native language, things like that.
So one of the common ones, I think REXML used to use the underlying Apache XML lib. So this is one case where there was open source libraries that were built for processing XML. And on most Unices, they're a standard thing to be delivered. So like if you're on a Mac, you have XML lib underneath and it's installed. Same thing on Linux, or it's easy enough to get. The problem is that there wasn't a version for Windows. And what you will often find is that your native C extension won't compile if somebody's trying to load the gem on Windows, which is one of the reasons why a lot more people went with fully Ruby gems instead of writing parts of it in C, is because it was difficult for Rubyists that were just Rubyists and not, full core Windows developers having the full development environment installed to get things to compile. So now this is back in the day. Some things may have changed, in the last few years for that, but that's one that I thought of. Some of there are some libraries probably for dealing with things like Raspberry Pis and stuff like that are dealing with things at a sockets layer that you'll probably find have native extensions.
Right on. Yeah, that's a pretty good point, actually.
Yeah, actually, one I just thought of. Here, I'll just share the screen again. Is I believe most web servers for Ruby have native code. Like this one is Puma, which is a pretty common one that Rails apps use. You can see here like the HTTP parser is written in C. Because again, this is like HTTP parsing has to happen on every request that the server serves, so you need that to be fast if you can. And probably SSL, I bet, would be another one that is can be computationally expensive, so that you can see here, this is, I don't know exactly what this file is, but it has something to do with SSL on the Puma server. So things like that would probably be good places to look if you're interested in what Ruby gems and libraries take advantage of native extensions.
That's pretty cool. Yeah, so I think we're out of questions from the chat. So have you got anything final you'd like to add there, Karl?
No, not off the top of my head. I hope this was useful to everyone. Thanks for coming out.
Oh, it was a great presentation, Karl. Thank you very much. It was. I haven't built any native, so I mean, even though I have some C in my past, I've stayed away from it, probably because I have C in my past. I didn't want to go back there, right?
Yeah.
It's always interesting to see because there's little, even if you're not going to build something, knowing how it connects underneath, right? Like, so, you know, I'm sure that when you're looking at your actual objects that you're defining in pure Ruby, that a lot of the stuff that you were showing today is what's happening under the hood to make these things real. And it's always useful to see and understand that.
Yeah.
Yeah, we do have one final question from chat that squeaked in here last second. Uncle Luke Chilton's asking if you use RBEnv on Mac OS.
No, I use RVM.
Right on. Yeah, thanks again very much. It was a very interesting talk, Karl, and it's nice to get a look into those deeper levels that you don't normally have to think about, so you get a better understanding and appreciation for them. So that is the end of the Ruby Meetup for the month of April. We are going to try this again, hopefully in the month of May, and I assume it might be the way that we run things for the near future indefinitely. And we'll see how things go when things start to relax. But thank you for everybody who came to take a look at our first virtual meetup. And hopefully things are a little bit smoother next time. But we've got some nice lessons learned from this one. And we'll see you all next time.
Bye, everyone.
Thanks all.